Hey everybody, you should have received the review through email. I'm going to go ahead and jump right into it and start solving some of these questions. So the first one being 5 times the sum of x and 3 is 4 less than twice a number. So 5 times, it says the sum of x and 3, so meaning sum meaning plus, in parentheses, is meaning equals, 4 less, meaning minus 4, twice the number x, so 2x. Then it says to solve, so we're going to go ahead and solve by first distributing 5 times x plus 15. It's 5 times 3, and then 2x minus 4, nothing changes over here. Then you want to move over the smaller one of the two, so I'm going to subtract 2x from both sides, which over here would give me 3x. And on this side, the 2x's would cancel out if I minus 2x on both sides. Then I want to get the variable by itself, so subtract 15. 3x equals to negative 4 minus 15 is negative 19. Divide by 3, you get negative 19 over 3. And the fraction's okay. So again, we distribute. We get the variables to one side, we get 3x over here by subtracting 2x, and then you subtract 15, you get negative 19, and divide. So let's look at the second one. The sum of 2x and 7 is the same as 17. Okay, so for this one, the sum of 2x doesn't work. The sum of 2x and 7 is the same as 17. So is being equals again, and we want to solve this. So I just subtract 7 from both sides, you get 10, then you just divide by 2, you get 5. Okay, so that's how you would solve that equation. Now 3, you have a fraction, so we'd always say if you have a fraction, let's get rid of it. So how am I going to cancel out division by 3? Right from the start, I can just multiply by 3. So I'm going to do this, multiply this by 3, and then this side by 3. You have to distribute the 3. 3 times 1/3 cancels out, which is x, and then 3 times negative 7, negative 21. 4 times 3 is 12. And then I just add 21 to both sides. That's going to give me 33. And I'm done. So this one we kind of encountered a little bit up here, but this time you just distribute twice. So let's get to it. So negative 4 times both of these. Negative 4 times 3 is negative 12. Negative 4 times negative 5 is positive 20x. 4 times x is 4x. 4 times 6 is 24. And we're going to solve again. Again, look for the smaller of the x's. I'm going to work with this one, subtract 4x from both sides. I end up with 16x equals to 24. Then I want the x by itself, so I'm going to get rid of the minus 12 by adding 12 to both sides. I get 16x equals to 24 plus 12 is 36. And then I just got to divide by 16 so that I can get x by itself. Divide both sides by 16. And anytime you can reduce, you should reduce. So what goes into both of these? 4 goes into both. 4 goes into 36 9 times, and 4 goes into 16 4 times. So the answer is 9/4. Okay. Next question, again, we have that issue of we have a fraction or fractions. Okay, so what we want to do is multiply by the least common multiple of all the denominators, which is going to be 18. So I'm going to multiply both sides by 18, and this is going to look a lot easier, but you can think of this as 18 times this one, but you have 18, it's kind of like 18 divided by 9, so it's actually 2 times 4 plus x, because the 18 divided by 9. And then you're going to do 18 times this one, but that's really like 18 divided by 3, so that's actually going to be 6 times x minus 5. And then over here, the 18s will just cancel out, leaving you with -6. Now this looks a lot easier to solve. We're just going to distribute. So 2 times 4 is 8, plus 2 times x is 2x, 6 times x is 6x, 6 times -5 is -30. And we're going to combine like terms on this side, meaning 2x with 6x is 8x. 8 minus 30 is -22. Then we'll just we want the x by itself, so the opposite of -22 plus 22. So 8x equals 2, 16, and finally divide both sides by 2. You end up with 2. Okay. Here you'd want to start like doing anything else. You'd subtract p. But when you subtract p on both sides, the p's cancel out, leaving you with -5 equals 9. So that's not right. But when you encounter this where the variables cancel out, if they don't equal, there is no solution. Now what if they do equal? What if it was like p minus 5 equals p minus 5? Then that would mean what we call infinite solutions. Any value would work for that. Okay, so moving on to 7. 7 wants you to solve for a variable, so we need to be able to do that. So here, one way we could approach this is multiplication. So I want to undo all this and get m by itself. So I'm going to divide both sides. Instead of multiplying by z, I'm going to divide both sides by z. So we'll do it step at a time. And then what's left over here, if you divide by z, is p plus m. Okay, so we want to solve for m. So there's only one thing left to do. I'm going to put this line just to make sure we understand that z. If I want to solve for m, I'm going to just take away p from both sides. So w over z minus p equals to m. And that's the final answer. Okay, so on 8, it gives you the graph of f of x, and we want to find the domain. So for that, you just look for the list of all possible x's, or in other words, look at the graph. What's the lowest that this graph gets to on the x? Well, it keeps going, so the lowest is actually -infinity. And what's the highest x? Well, same thing. It's going to keep going in that direction, down and to the right. So the highest is infinity, so therefore the domain on A, we would write -infinity to infinity is our answer. Okay, and you would want to write it like that. Keep in mind this test will be free response, so you got to make sure you understand the notation. So practice that. What is f of -2? Well, this simply says on the graph, when x equals -2, what's your y coordinate? Well, your y coordinate here is 3. That's all it's asking. So when x equals -2, what's y? It's 3. Now it also says when f of x equals 3, what is x? What is x? So we kind of answered that question in a sense. When in other words, when the y coordinate's 3, what's x? Well, it's 2. X equals 2. Okay, so that's kind of the other way. You start with the y, and you want to know what x is. Okay, that you could be asked another way, like maybe what is it when x equals 0? Which there would be multiple answers, but I'll leave it at that one. Here, we want to know, they give you t of r, this equation. What does this mean? That means you're just going to substitute -3 for your variable. So that's what we're going to do. So t of -3 equals 5 times -3 squared minus 2 times -3. Square that would be 9, so I have 5 times 9. Minus 2 times -3 is actually going to be plus 6. 4 times 9 is 45. 45 plus 6 is 51. So my answer is 51. Similar thing on 10. We'll be asked to do f of 2. So What does that mean? Substitute 2 for x. So 2 times 2 squared minus 5 times 2 plus 2 equals 2 squared is 4. 4 times 2 is 8. Minus 5 times 2 is 10 plus 2. 8 plus 2 is 10 minus 10 is 0. So the answer of f of 2 equals 0. Alright, so moving along, we're going to do the next one, which asks for x and y intercepts. Now, how do you find an x-intercept? Set y equal to 0. So that's what we're going to do. In the equation, 5 times x minus 2 times 0 equals negative 10. Well, we know 2 times 0 is just 0, so we have 5x equals negative 10. Then we're going to divide by 5 and we'll get our answer. X equals negative 2. In other words, our coordinate is negative 2, 0. Okay, that's our x-intercept coordinate because we set y to 0. Now, how do you find a y-intercept? Well, set x equal to 0. So we're going to do that. 5 times 0 minus 2 times y equals negative 10. We know that's 0, so it's negative 2y equals negative 10. Divide by negative 2, we get 5. So we know our coordinate is 0, 5. Okay. It doesn't ask us. Oh, it does ask us. Okay, so we want to graph this, which is not hard. Negative 2, 0 is right here. 0, 5. There's my y-intercept. There's my x-intercept. Draw the line. As long as I can draw the two intercepts or plot the points, then I have my equation. So you want to be able to graph when given an equation like this on 12. Make sure that you label in at least 2 points. Okay, so this is in slope-intercept form, y equals mx plus b. So we would start with our y-intercept, and then from there, the slope is going to tell us the next point. So from the y-intercept, you're going to go up 1, rise 1, run 3. Up 1, run 3. There's my line. Okay. So that's all there is to it. Now, if it was negative, then you would fall and then run. Okay, always to the right, but the negative determines whether it's positive or negative determines whether you rise or fall. Okay, whether you go up from left to right or fall from left to right. Okay, so on 13, we're asked to determine the equation of the following lines, and I took it a step further just so you can see, but I'm going to graph them too. So we want the horizontal line that contains 1, 5. So 1, 5 would be right here. I want a horizontal line that goes through there. Well, that's the equation y equals 5. Okay, any horizontal line is written as y equals 5, or y equals whatever number it goes through on the y-axis. 14 says you want a vertical line that goes through 1, 5. There's 1, 5. I want the vertical line. Any vertical line is going to be x equals to the number that it goes through on the x-axis. So in this case, it's x equals 1. And finally, we want the graph of, or the line, the equation of 3, 5 and 3, 9, which are those 2 points, which also happens to be a vertical line that goes through 3. So that is, again, another example of x equals the number it goes through on the x-axis if it's a vertical line, so it's x equals 3. So that takes care of 13, 14, and 15. On to 16, we're going to do some simplification. Now, this minus parentheses here that you'll see, I didn't draw the other one, but it's not really going to make a big deal. Well, you can kind of think of this as like 1, and you distribute, so the parentheses just kind of goes away, in other words, on the first part. Now over here, you would distribute kind of like a negative 1, so that would be negative p to the third z minus 5z Then -1 times -4, that'd be +4. Now combine these like terms. So 5p cubed z minus p cubed z, that's like 1p cubed z. That'll give you 4p cubed z. Then -9z minus 5z, that's -14z. And 9 plus 4, that's 13. So that answers that question. And moving on to 17. So on 17, we just want to use some distribution. So we're going to multiply -2x squared y times 9x. So I'll start with the 9 and the 2. So -2 times 9 is -18. X squared times x is x to the third times an extra y there. So that's times the first one. Now we're going to multiply this times the second right here. So -2 times y is going to be actually a +2. X squared, and then y times y is y squared. And that's it for that problem. Here, we're going to multiply the 2x times these two. So 2x times 5x, that's going to give us 10x squared. 2x times 6, that's going to give us 12x. And then we're going to multiply the -5 times these two. -5 times 5x is -25x. -5 times 6 is -30. Alright, so combine like terms and we're done. 10x squared, 12x minus 25x, that's -13x minus 30. Okay, so now finally, we're going to do 19, which is kind of like this problem, because it's squared, so that actually means you're going to times this times itself. So let's get started. You can do 5m times both of these. 5m times 5m is 25m squared. 5m times 3 is 15m. And then now we're going to do 3 times both of these. So 3 times 5m is also 15m. And 3 times 3 is 9. So 25m squared. Combine these like terms. 15 plus 15m is 30m plus 9. And that's our answer. Okay, so on 20, and through 23 really, we want to factor these problems. So they're all different types. So here you have 3 terms where the lead term is 1. So when that's the case, you just look at, remember we talked about A, B, and C. We're going to look at the factors of the C term, which is 15. So the factor of 15 are 1 and 15, 3 and 5. And that's all the factors that there are. So we want to see which combination of these will give me the -2. And I want to factor like this. So obviously it's going to have to be 3 and 5. But it'd have to be -5 and +3, because again it's going to have to multiply to -5. -5 times 3 has to multiply to -15, and -5 plus 3 has to add up to -2, which we have accomplished, and we have answered this question and factored. Now on 21, you see that there's only a 2 term here, so I can factor this out. I'm going to start with the coefficients. We're going to look for what's the greatest common factor, okay, out of all these. So starting with 18 and 8. 2 goes into both of these, and I think that'll be the largest number. So 2 is the greatest common factor. What's the greatest of the x's that I can factor out? Well, x to the third, okay? Because I can't factor out x to the fourth because this doesn't have x to the fourth. So what's the greatest of the y's that I can cancel out? Well, y to the fifth. I can't factor out y to the seventh because this does not have y to the seventh. So y to the fifth. And then now you're just going to divide this term, 2x to the third, y to the fifth, from both of these terms. So 18x to the fourth, y to the seventh, divided by 2 x to the fourth divided by x to the third is just x. Y to the seventh divided by y to the fifth is y squared. Do the same thing over here. 8 divided by 2, that's -4. -8 divided by 2. And then x to the third divided by x to the third, that's 1. So I'm not going to write that. Y to the fifth divided by y to the fifth, that's 1. So I'm pretty much done. I might want to fix my parentheses here so it doesn't look like it's in the middle of nowhere. There we go. Going to 22. Here you have, on the first one, a was 1. So you can just factor the c term. On this time, a is not 1. So it's another number. It's 4. So what you could do is what we call it like an AC method. Do 4 times 30. It's 120. And we're looking for factors of 120. 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, and we can keep going, but then also if you see the answer, like I can see that this will work. It can give me 19. Then you can stop from there. Okay, so this, we want to kind of split these up. So I want to split the 19 term up into plus 24a minus 5a. So that's how I use this, and I'm doing this for a reason, because I want to set up factoring by grouping, which you have two groups. You got your first group, you got your second group. Remember, there's like this plus in between. So greatest common factor of the first group would be 4a. So divide that by 4a, you get a. Divide this by 4a, you get 6. And then the greatest common factor in the second group seems to be -5. So divide by -5, you get a. Divide by -5, you get plus 6. And then you should notice that there's an a plus 6 here and a plus 6 here. So we can factor that out, leaving with a plus 6. What's left over? 4a minus 5. We have factored this. Alright, so the final type of factoring here that we'll see is this. We call this a difference of squares. There's only two terms, and there's a minus here. So anytime you have that, I'll just kind of show the rule. It's a squared minus b squared equals to the subtraction of a and b times the addition of a and b. That's what we call a difference of squares. A being the square root of all this. So what's the square root of all this? Is 10x. What's the square root of 9? It's 3. And the other factor will just be the same thing except addition. And we factored that. So on to 24. The question asks, find the area of the unshaded region, which would be two rectangles. So we want to find the area of both, right? So here's the idea. I want to find the area of the large, I'm just going to call it area of large rectangle minus area of small or shaded equals area of unshaded. Okay. That's the overall goal. So we know a rectangle is length times width. So this is the length, that's the width. So I'm going to find the area of the large, which is 2x plus 3 times 4x minus 7. Okay, so we kind of did this before on this video already, so we're going to do 2x times both of these. 2x times 4x is 8x squared. 2x times -7 is -14x. And now we're going to do 3 times both of these. 3 times 4x is 12x. 3 times -7 is -21. Combine any like terms, you get 8x squared minus 2x minus 21. Okay, so that's the area of the large rectangle. Now I'm going to do the area of the shaded rectangle. Okay, so that's 2x minus 5 times 4x plus 5. Okay, so we'll gather this information. So we're going to do the same thing. 2x times both of these. That's 8x squared. 2x times 5 is 10x. Then we're going to do negative 5 times both of these. Negative 5 times 4x is negative 20x. Negative 5 times 5 is negative 25. Okay. Alright. And combine like terms. 10x minus 20x is negative 10x minus 25. So, I'm going to have to kind of work up here somewhere. But we have the area of the large and the area of the shaded. We're going to subtract these two. So I'm going to kind of write, you know what, I'm going to erase this, a little bit of this rectangle. Put my answer up here. So I'm going to do the large first. 8x squared minus 2x minus 21 minus the area of the small. 8x squared minus 10x minus 25. And we're going to subtract them, but I have to distribute. So we've kind of seen a problem like this too. And remember I told you like the 1 doesn't really matter. It's going to be the same thing. You just kind of lose the parentheses. Over here it's negative 1. So it's going to change it up a little bit. Negative 1 times negative 10, that's positive 10x. Negative 1 times negative 25. All that happens over here is the signs change. We'll simplify. The 8x squared minus 8x squared, that goes away. Let's cancel. Negative 2x plus 10x, well that's 8x. Negative 21 plus 25, well that's 4. So the area of the unshaded is 24. Okay, so that's the area of the large rectangle minus the area of the small rectangle. Okay, so last set of questions. I'll jump right into them. This is kind of like your last test 4, rational functions, adding, multiplying, dividing. Okay, so we'll go ahead and start here. Now on 25, you want to start with factoring. A is 1, so you want to get factors of 72. 72 is 1 and 72, 2 and 36, 3 and 6. I'm sorry, not 3 and 6. 3 and 24. 3 and 24. 4 and 18. 5, 6 and 12. And what else are we missing? Not 7. 8. Not 8, 9 and 8. Okay, which that's going to be the one. So on top, it's going to factor to x plus 9, x minus 8. Because that multiplies the negative 72 and adds up to positive 1. Okay, so that one works. I'm going to go and erase this for space. Now I'm going to do the same thing for the bottom. I want factors of 80. So 1 and 80, 2 and 40, 3, no, 4 and 20, 5 and 16, 6, no, 7, no, 8, and 10, which that'll be the one. So this will factor to x minus 8 and x minus 10. They both have to be negative because negative 8 times negative 10 is positive 80. Negative 8 plus negative 10 is negative 18. So now you should notice something cancels, right? So we'll cancel those out. And the remaining is our answer, x plus 9 over x minus 10. Okay, so again, on these you want to start with factoring. If something factors, then you should factor it. So similar here, I'm going to factor the top, which I see on top, there's a common factor of 8. So we'll start there. So I'm going to factor 8, divide that by x squared, minus, divide that by 8, you get 9 over 5. And then on the bottom here, there's a common factor of 4 times, divide that by 4, divide that by 4, you get x minus 3. We should notice that your 8 and 4 are kind of, if you divide it, you get 2, you're left with 2 on top. The 5's there, but what about this? This is a difference of squares we talked about earlier. So I can write this as x minus 9, or not 9, but 3. X minus 3, x plus 3. times 3 over x minus 3. Remember that we took out the 4 by dividing by 8. Okay, so we should see some other stuff cancel out, like the x minus 3 will cancel out here, and I can multiply the 2 and the 3, which would give me 6 times x plus 3 over 5. We'll go ahead and distribute. That's going to be 6x plus 18 over 5. Okay, so on 27, we're going to want a common denominator. So first we'll look at the numbers in the denominators, which is 12 and 15. And usually if you go by the larger number, 15, 30, 45, 60, you'll run into the one that's the common denominator, which will be 60, because 12 times 5 will give us 60. So this is also missing an x, so I'm going to multiply this by 5 over 5, but I want this to have an x squared too, so let's multiply this by x as well. So this side will give us negative 5x times negative 3, negative 15x. 5x times 12x, that's 60x squared. Now still here on this side, we want that same common denominator, so I need to multiply this one by 4 over 4, because this will give me 16 over 15x squared times 4 is 60x squared. And now I have common denominators. Now why do I want that? Because now I can combine these into one fraction, which will give me negative 15x plus 16 over 60x squared. And that'll be my answer. Now, I think 28 probably should have gone first, actually, because this one already has common denominators. So therefore, we can just add them as is. So we end up with p. So I just switched it. I put the p first. Since they have common denominators, I can just combine them as one. However, there is an additional step. You should notice that this is a difference of squares. So I can break this down to p minus 4 over p plus 4, which you'll also notice that the p minus 4's cancel out. But it's not just, the answer is not p plus 4. When they cancel out, that means there's something divided by itself, that means it's 1. So the answer is 1 over p plus 4. 1 over p plus 4. And then, so finally on this problem, we want to solve for x. So you have division by 5. Again, if you can get rid of the fraction, then let's try that. So if we multiply both sides by 5, we end up with just that cancels, that cancels. So hopefully we're okay with that. Now I'm just going to distribute. You end up with 6x plus 18 equals to 6x plus 18. Now, if you subtract 6 or 18, you'll end up with, or subtract 6x actually, you end up with 18 equals 18. Which, this is what I was talking about earlier. The variables are gone, but the last time we did it, it was something like 2 equals to a different number. But now you have 18 equals 18, so this actually tells you there's, the solution is infinite solution. And it's all real numbers. Okay, so that's the answer, all real numbers. Okay, so final one, 29. Well, we want to add those together, but we don't have common denominators. So again, the first thing you should try is to factor so that, and I'm going to go ahead and just do this one. This would be 5 times 7, so m plus 7, m plus 5. You can make the list like I was doing earlier. Now, if I factor it out, I can see what's missing over here. What factor is missing so I can get common denominators, the m plus 7. Right, so now I'm going to multiply this one times m plus 7 over m plus 7. I'll work that out. So 3m plus 4 over m plus 7 times m plus 5. I just rewrote this side. Let's distribute this. M times m is m squared. M times 7 is 7m. I'm going to do 2 and 1. So that m times 7 is 7m, and then negative 3 times m is negative 3m. So that turns out to be 4m. And then negative 3 times 7 is negative 21. Okay, so you might have to fill in a blank a little bit there, but basically I just did negative 3 times n is negative 3m, and then 7 times m is 7m. Add those together is 4m. Really for space purposes, because I'm running out of space here. But now I have common denominators. What does that mean? I can combine these into 1. So m squared, I'm going to put m squared first. 3m plus 4m, that's 7m. 4 minus 21, that's negative 17. On the bottom, you have m plus 7, then times m plus 5. Now, we still want to check, and I'm going to erase a little bit. We still want to check that or make sure that nothing cancels here. So we want to factor the new polynomial we have on top. So factor the 17 if we can, but it turns out there's nothing that's going to go into that. So we have it. This is the answer. The only other possible way you could see it is to actually multiply out the m times m is m squared. M times 5 is 5m. 7 times m is 7m. That adds up to 12m. I did my little shortcut there. 7 times 5 is 35. Okay. If you need to do the extra steps to get to that, then go for it. But that's it in a nutshell. Now, I wouldn't assume you have it down. Make sure you study. Make sure you you might do these same problems cold, and practice. Right? So the final won't be multiple choice. You have to write stuff out like this. So prepare for that. Prepare to answer these things cold. Turn this in completed on Wednesday when I see you for your final. All right, see you then.